Welcome back students to CL Academy. I am your Bhanu ma'am and this is our second class on exploring forces. Yesterday we learned about forces and let's do a quick recap of what we learned. So yesterday first we learned about push and pull. When you push something it goes away from your body and when you pull something it comes closer to your body. Then we learned about what is force. So, force is a push or pull on any object. Then we learned interaction is necessary. First, to apply force, there needs to be an object. Without anything, how can you apply force? So, first you need an object. Then second, there must be some kind of interaction between the two objects for force to appear. For you to apply force, so we learnt about interaction is necessary for force. Then we learnt about the unit of force, that is Newton. Then we learnt about the changes, the effects of force on objects. There are 4 specific effects that forces have. First is when we apply force on an object, the shape of the object changes. Then when we apply force on an object, we can move it from rest. Thirdly, when we apply force, we can change the direction of a moving object. And fourthly, when we apply force, we can change the speed of an object. Then we learnt about balanced and unbalanced forces, students. And similarly, there are forces of 2 other types, which are contact forces and non-contact forces. So now let's assume when you are kicking the ball, when you are pushing a door open or pulling the drawer open, you need to touch the objects to apply force on it. You need to come in direct contact with the object to be able to apply force on it. So in this case, the force we apply is called contact forces. But there are some cases in which we will not the force is being applied but we cannot see it, we can only feel it. In those cases it is called non-contact forces. So now in contact forces we will learn about 2 specific type of forces. What are those, students? We will see. Those are muscular force and friction force. So students, yesterday we learned that we perform millions of chores every single day, like opening a door, jumping, chewing our food. To perform these chores, students, we need to take the help of our muscles. Without these muscles, we cannot perform these chores. We cannot apply force. That is why the force which occurs due to the action of muscles is called muscular force, students. Here it is written the definition of muscular force. The force resulting due to the action of muscles is known as muscular force. So, for there to be the action of muscles, what do muscles need to do? They need to contract and elongate. Now, let's take the example of heart here. And what we are learning about? We are learning about muscular force. So, let's draw a heart. What does heart do, students? Heart pumps blood into the veins of humans and that is very necessary for the sustenance of humans. So, how does the heart do it? The heart sometimes elongates Sometimes the heart contracts or shrinks in order to pump blood. This is an example of the contraction and elongation of muscles. And this can be taken an example of muscular force. Then again we come back to the topic. Then there comes a very special force, that is friction force. So let's imagine Sonu. Let's take the example of Sonu here. We are trying to understand friction force. Let's take the example of Sonu. Sonu is our sada sida bachcha. He is healthy and he studies well. So he is in the ground practicing football. He kicks the football and the football moves, travels certain distance and then stops. First, as he kicks the ball, the speed of ball increases, then the speed of ball decreases, then it stops obviously. So we know that to change the speed of a moving object, there needs to be a force. Without any force, there cannot be a change of speed. So now we know there is some force acting on it. Some force acting on it. Now you ask me, who is applying the force? Sonu kicked the ball, but who is stopping the ball? So in previous lecture we also learned that for force to appear, there needs to be interaction. So the ball is only interacting with the ground now. As it is only interacting with the ground, then the only force that is applied on this ball is applied by the ground obviously. And students, let's take another example here, then we'll come back to it. There is this box. This is Sonu and this is Lipu. As they are pushing the box, it goes away and away. It does not stop. But there is the same box. Here is Sonu, here is Lipu. They both are pushing the box, so the box is not moving. So here Sonu applied the force in this direction. So the ground needs to apply the force in opposite direction in order to stop the ball. So the force that is applied by the surface when an object moves on it is called friction. Here the definition. Here the definition of friction force, we see the force that comes into play when an object moves or tries to move over another surface is called friction. Is here when the ball is moving, so the force acting on it is friction force. And who is applying the force? Ground is applying the force. And this force is being applied in the direction opposite to the direction of motion of the ball. The direction is opposite. Opposite to the direction of motion. we learnt another thing in the definition, that the friction is applied when the body moves or tries to move. What does that mean? The body moves or tries to move. This part we understood in the previous slide. What do they mean by tries to move? So now let's remember the example we took of Preeti. So here is our Preeti and here is the box, heavy box. The box is very heavy as Preeti's things are here. So heavy box. So Preeti is facing great difficulty to push the box. She starts pushing the box. She starts pushing the box, but the box does not start moving immediately. After some time, it moves. When it starts moving, we know there is friction acting on it. But we see here there is a time lapse between Preeti trying to push the box and the box actually moving. So here the question arises, is there no friction when Preeti is pushing and the box is not moving? So students, the answer is yes. When the box is not moving, yet there is friction working on the box. When the force with which Preeti starts pushing the box increases the friction force, increases more than the friction force, then only the box starts moving. So now we have understood the definition of friction. Now we know about muscular force and friction force. And as we know, force is of two types, contact force and non-contact force. Now we'll learn about non-contact force. As I told you previously that some type of forces that we do not see being applied with naked eyes, but we can feel the effect of those forces. These are non-contact forces. These are mainly of three types, which are magnetic force, electrostatic force, and our favorite, gravitational force. So we'll learn about those now. Magnetic force. So let's learn the definition first. The force exerted by a magnet or another magnet on another magnet or a magnetic material is called force. Let's try to understand with the help of an example. We'll take some examples here. Magnetic force. So we all know about magnets. There are different type of magnets, bar magnets, circular magnets. So we'll take two bar magnets here. Bar magnets. We all know magnets have two poles, North Pole, South Pole. Here also North Pole, South Pole. We know one thing about magnets, that is similar poles repel each other and opposite poles attract. We have here one magnet's north pole and another magnet's north pole. If we try to bring them closer, what will happen, students? They will repel each other. They will repel each other. They will push each other. So we know that push is the force. So they are applying force on each other, and this force is none other than our magnetic force. Similarly, there is a stick, and here also we take two magnets, two circular magnets. This is the north pole, this is north pole, and if we try to bring them closer, they will repel and we can feel it. So we can try this example at home to better relate. And in the definition we learned about one more thing, that is the force exerted by a magnet on another magnet. Another magnet that we studied, but one more thing is written, or a magnetic material. What do we mean by magnetic material? For example, magnetic material are the materials which are attracted towards magnets. So we can take the example of iron here. We can take a piece of iron and we can take a magnet. And we can see that magnet attracts the iron. It pulls the iron towards itself. That is, it applies some force on the iron, and that force is none other than our magnetic force. Then we learn about electrostatic force. So first we learn the definition. When two objects of certain materials are rubbed together, electrical charges build up on their surfaces. These charges are called static charges as they do not move by themselves. So let's try to understand it. Electrostatic force. Let's take a stick. Let's take a polythene. And let's rub these two together. When we rub the stick with the polythene, what do we see? That some amount of charge is developed on the surfaces. So first we need to know charges. Charges are mainly of two types: positive charge and negative charge. And one more thing we need to know about charges is similar charges repel and opposite charges attract. It is similar to the north and south pole of the magnet. The similar charges are repelling and opposite charges are attracting. And when we rub two things, we see one more thing. The charges get developed on the surfaces of these objects, and one more thing happens is that the charges that are being developed are of opposite nature. That if positive charges are developed here, negative charges are developed here. So now these charges that are being developed on the surfaces, they do not move. That is why they stay where they are. So that is why we call these charges static charges. We learned the definition in the PPT. Charges. Charges which do not move. Do not move. And the objects on whose surface the charge is being accumulated is called charged object. So, as a charge is accumulated on the surface of the stick, it is a charged object, and the polythene also a charged object. Charged object. Now, we take the charged stick. Charged stick. We take some bits and pieces of paper and we bring them closer. The stick and the bits of paper, we bring them close. So what happens, students? The bits and papers stick to the stick. How do they stick to the stick? The stick is attracting these bits. So the stick is pulling these bits towards it. So the stick is applying force on these bits. So this force is called electrostatic force. We can take another example here, students. Let's take a table. Let's take a table. Let's attach two strings and balloons with it. And we'll take a towel. We take a towel and we rub the balloons with the towel. Then what happens, students? Similar to the previous scenario, charges get developed on the surfaces of balloons and on the surface of towels. And the charge that is developed is first static charge, and secondly, the charges are opposite in nature. Then we take away the towel and we are left with two balloons. And when we try to bring those balloons together, what happens? They push each other. They go away from each other. They apply force on each other. This is an example of electrostatic force. Static force. And then again we try to bring the towel closer. As the charges developed on the surface of towel and balloons are opposite in nature, obviously the balloon will be attracted toward the towel. So there is also electrostatic force. Static force. Now return to the slide. When two objects of certain materials are rubbed together, electrical charges build up on their surfaces. These charges are called static charges. We learned about static charges, student. They do not move by themselves. Then the object that acquires static charges is said to be charged object. Then we know the definition of electrostatic force. The force exerted by a charged body on another charged body or uncharged body. Here we see one charged body applies, the towel is a charged body and balloon is another charged body. So here the towel, a charged body, applies force on another charged body. And in previous slide we saw that the stick is a charged body but the bits of paper are not charged. So the electrostatic force, a charged body can apply force on another charged body or it can apply force on an uncharged body. Now we learn about gravitational force. Now let's try to understand with the help of an example, then we'll return to the slide. Gravitational force. So let's take the example of Preeti. Preeti is here on the ground and she has a ball in her hands and she throws it upwards. She throws the ball upwards. First, we know the ball will go with greater speed, and then the speed will decrease, and at a point its speed will be 0, then it will return to Preeti. So as Preeti threw the ball upwards, but the ball came downwards, so the direction of the ball has changed. So what do we see? So what do we know? That to change the direction there must be some kind of force. So who is applying force here? Who is applying force here? Applying force. As we are learning about non-contact forces, we cannot actually see who is applying force, but the force is being applied. Here, the earth is applying force. Applying force, which is known as the gravitational force or gravitational pull, as the earth pulls everything towards itself. So now since all the objects fall towards earth, we saw the ball fell towards earth, it means the earth attracts them. The force with which the earth attracts objects towards itself is called gravitational force. Then gravitational force exerted by earth is also called force of gravity or simply gravity. Then we now know about gravitational force. Now there is a very important concept that we need to know, that is the concept of weight. We learn about weight. In our day-to-day life, we use weight far too many times, but we do not know what weight actually means. So now we'll learn about mass and weight. First, let's see what is mass. Mass is the amount of matter present in a body. Present in a body. And we know mass has unit gram, kilogram. Then now let's learn about weight. What is weight? Weight is the amount of force that earth applies on a body. Many times we confuse mass with weight, but the unit of weight is same as force, as it is a force. It is Newton. In short form, we can write it as N. So we see mass is a quantity which do not change, but weight may change. Now let's take an example. As there is our mass, and there is weight. As weight is the gravitational pull of Earth. Pull of Earth. It can change. If we go to, let's say, moon, you may have learnt that in moon your weight becomes 1/6 of weight on Earth. It happens because the gravitational pull of moon is 1/6 times of the gravitational pull of Earth. So if in moon you have 10 gram mass, if in Earth you have 10 gram mass, if your weight on Earth is 10 Newton. Okay, so in mass, in Earth you have mass 10 gram. In moon also you have mass 10 gram. As mass is the measure of matter in a body. But in Earth you have weight 10 gram, 10 Newton, as weight is measured in Newton. In moon your weight will become 1/6 times. So here you see the difference. What mass and weight is. Generally we may confuse weight with mass, but from now on make sure that you are not confused with that. So let's come to the slide again. What is weight? The force with which the earth pulls on an object towards itself is called the weight. Then it is measured in the same unit as that of force. As it is a force, as it is a pull, it is the pull of earth. Then weight is also, the SI unit of weight is also same as force because it is a force. It is Newton. Then we will learn about spring balance system. And you may ask, now we know the difference between mass and weight. How is weight measured? So we take the example of spring balance system to measure weight. So that is written here. A spring balance is a simple device used to measure weight. So let's try to understand spring balance better. Spring balance. So first let's take 3 hinges and 3 springs, and in each spring we attach a mass. Here it is M, it is A, it is B, then it is C. We see as these 3 objects have different masses, the earth pulls it and the spring gets stressed. So the more the mass, the more the spring gets stressed and more will be the weight. Then try to understand spring balance. This is let spring balance. Spring balance. In your schools you may have spring balance, so understand it here and try to apply it in your schools. In spring balance, in one side we have written, there is written weight measurements in Newton, and mass measurements in gram. So it may be written as 0, 0, 1, 0, 2, 0, 3, 10. Here it may be written 100, 200, here 1000. So this is our spring balance. So here between two big divisions we have 5 small divisions. Here we attach a mass and we see how much the spring gets stretched, and accordingly the weight, it indicates the weight, and here we can see the mass as well. Now we learn how do we know the least amount of weight that can be measured in a spring balance. Least amount of weight. So one small division to calculate the least amount of mass that can be measured, we need to calculate what does this one small division measure. So to calculate this, first we need to know this big divisions, they measure the weight 1 Newton, and we have here 5 small divisions. So how many divisions we have? 1, 2, 3, 4, 5. So one small division is 0.2 Newton. So 0.2 Newton is the least amount of weight that we can calculate with the help of this spring balance. But the spring balance in your school may have different values. So it's one small division may be different. You can calculate it and say it. Now we know about spring balance system. Now let's learn about buoyant force. So you may have noticed that there is some amount of water. If you try to let's take the example of a bottle. When you try to keep the bottle in the water, what happens? It might sink or it may float. So why do some objects sink while other objects float? So this is the concept of buoyant force. So let's take a bucket, and in bucket there is water. So we have a bottle here, and the bottle is floating. But now if we increase the mass of the bottle, we fill it with water, then what may happen? It may sink. Why is it happening? It is happening because of buoyant force. We know that on every single object a force is being applied. That force is gravitational force, gravitational pull, and that force is being applied in the downward direction. in the downward direction. But as we see, the bottle is not sinking. What does that mean? This liquid must be applying some force on the bottle so that it is not sinking. So that force must be in upward direction. This force is none other than our buoyant force. If and here also buoyant force is being applied, but the gravitational pull is more. That is why the bottle sank. Okay, now we understand what buoyant force is. Okay, so in today's lecture we learnt about two different type of forces: contact force, non-contact force. In contact force we learnt about muscular force, friction force. In non-contact force we learnt about electrostatic force, magnetic force and gravitational force. And then we learnt about the concept of weight and mass. Then we learnt about buoyant force. So I think you have enjoyed this lecture, and if you have any queries or doubts, you can let us know in the comment section so that we'll be able to respond to you in due time. Thank you.